So now in the last video, we looked at the photodiode, which we use reverse bias. So we have the short lead, the cathode, towards the positive supply, the long lead, the anode, towards the negative side, which we got a capacitor here. We can also short to ground with this switch to discharge the capacitor, because the capacitor is actually should be fully charged by now, long ago. But any case, it doesn't create current when you put light on the photodiode right there. It's not like a little solar cell. Instead, it just lets current conduct through it based on light level that we're going to see here. So we don't really need the 220 ohm resistor to limit current, but just in case the photodiode doesn't limit it enough, I also added a 220 ohm resistor. That's a good resistance to use when you are working with 5 volts there. Now, this voltage we're going to measure, that's not to provide power to anything. If we have to provide power, current to anything, that's going to lower the voltage. We need all the current going into the capacitor in order for that voltage that we see to build up. And we could send that to an amplifier or something if we want to actually transmit that voltage to power something else for whatever reason. But in any case, capacitor will charge until it's fully charged, and it should be a ramp, should be a steady charge, because we're giving steady current to a capacitor. And it's a 1000 microfarad capacitor. So if the light level is set just right for 1 milliamp of current to flow, or if you used any other 1 milliamp current source, this is basically the same as 1 millifarad. 1 milliamp into 1 millifarad will give you a 1 volt rise every second. So now I got my pocket oscilloscope here. Usually I turn this lamp off to the side so we don't have as much light, but this circuit depends on light. And if we want to, we could turn the power on right now for the pocket oscilloscope, but I'm not going to yet. So yeah, we got this alligator clip. You can usually clip it to like the negative supply or something. Ground, I'm going to clip it to this jumper. That's typically what I do, and often you can peg it into the board to hold it in place, just an unused spot. And we're going to go to the negative supply right there. And we don't have to really worry about where we attach these. They don't let current go through them for the most part. They have, I think, like 1 million ohms of resistance. There is a, if I slide this over there, though, then I think it provides 10 million ohms of resistance. And it won't affect the voltage as much. You just got to remember, though, whatever voltage it measures, it's going to be 1/10 of the actual voltage. Yeah, so we could go to the positive supply. We are going to go to where we want that voltage, that signal there. So yeah, we'll get the charged capacitor, and then this switch discharges it. Now these switches, they pop out of the board. It's really not doing that well. So when I release it, it may not even be connecting to the board. But when I press it, it will definitely short it out. So I think I discharged the capacitor. But in case, let's turn power on. We should already have settings set pretty much to where I want. Actually, it's going to be a little bit off. So yeah, we have, there's 2 probes here. So this one is the green one, but we could turn the other one off. So green channel 2, that's one we got. So each square is actually 2 volts. And so we already have it showing, there we go, that'll look a little bit better. We already got the channel there, so I think if I hit the right arrow, it'll go up to 5. Yep, okay. So I want 1 volt per division. So now we are up 5. The other one's not really measuring anything, so it's showing like 0 volts. And I could get rid of that too. But yeah, it looks like it's a little shy of 5 volts. Now this may not be completely accurate. I can adjust it a little bit. But the power supply does lose a little bit of voltage when it gets to the circuit. And on top of that, we are measuring the capacitor. I'm going to move this light back now because we're dependent on the light falling on it. I want it to be like about as much as it was last time. And maybe the capacitor is not getting the full supply voltage. And yeah, it does look like it actually got the full supply voltage. So we got the full supply voltage because it's been sitting under the light here a while. So we expect that. I press a button, now it discharges. There we just, like when I moved the probe, I think. We weren't measuring anything. When I release it though, now you can see a steady voltage rise right there. A little curve at the end. But there you can see we had a steady voltage rise pretty nicely there. That though was with this light level here. So in the last video, I think it was somewhere like 1.5 milliamps of current was flowing. And I can't remember how to pause this. Okay, that button there. So actually, I wasn't looking. We actually got pretty much spot on there. So if it was 1 milliamp, we would expect to go right from that corner, which we are, to that corner, that corner, that corner, and that corner. And ideally up to 5, but there you can see it actually starts curving down, slows down towards the end there. So no big surprise. We'll pause that. So yeah, I think this is close to 1.5, maybe a little less milliamps of current. So depending on how I have the lamp and everything, might make a difference. Now we make it dimmer. You can see this looks a lot nicer. So usually I have the lamp like dimmed down, and this is not bad here. But sometimes still, if I see glare or something, I'll move the lamp out of the way. But yeah, I actually like how this looks. It may look different though when I edit it. But looking through the back of the camera, it looks pretty good. So going to release that again. Now you can see when we lowered the light here, I think we were a little more than, with the brighter light, more than 1.5 volts. So it's a little off to the left there. But there you can see, we're not even at, above 4 volts right there. But it's still a steady line because we're getting a steady light. And of course by now, it reached the top. It cleared out when I unpaused it. But yeah, the ramp is going to depend on light level. And you can also look at accumulated light. So it's slowly growing. When we get it brighter, it's growing faster, and then we could slow it down. So if we had more voltage, we could get higher, which we could actually do. Actually, we only have a 220 ohm resistor here, but it's not really setting the current. The PhotoDiode is right there. It's a somewhat decent current source, as you see there. We can get a steady voltage rise in the capacitor based on light level. Now it won't be stable if the light level is unstable, right there. But as long as the light level is stable, then we'll get a steady voltage rise. Otherwise, we could use like a much larger value capacitor right there and see like a longer period of time. It would take longer for it to charge. But we could like tell how much light it had seen over a period of time, and other things you can do. But otherwise, we have a light level that is or a ramp kind of that is set based on light level. But again, it's only a ramp, I think, if it's a straight line. Now it would not be a ramp. Now it's like reading a signal, light intensity, maybe you could say right there for. How steep the curve is, more light intensity, and when it flattens out, now we just topped out our maximum current. But otherwise, the more level it is, the lower the light level, and the steeper the line is, then the brighter the light. So yeah, hopefully that makes sense. But anyways, I'm going to turn this off. I'm not running on battery. If I was, it would keep trying to go to sleep mode. I'd have to keep hitting a button to prevent that from happening. But I got it plugged in to the USB right now. Actually, that's off. I turned this off, so the USB may have turned off. But in any case, not your problem. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.